Hey guys, Mr. Marone here. Welcome back in. We're looking at the last portion of section 7.4, which is one of the longer sections that we'll have all year. Just a little bit of a recap. When we talked about this section, we are talking about similarity in right triangles. And we said that if I'm given a picture like this right here, that I can break it into three triangles and kind of stack them all up so that they look the same direction. It allows us to match up common sides, and we came up with this big chart for us here, and then we discussed the idea of geometric mean and how this is what our real tool is for solving these problems. So if we look at our example in the first video, we talked about when we were given both the middle triangle and the smallest triangle. Now we're going to look at what happens when we're looking for one of the two legs of our right triangle. So we've got two options here. In this first example, we've got the littlest triangle and the largest triangle. And when you break them out and draw them apart and set up your ratios and all that kind of stuff, you get this ratio here, that the hypotenuse of the large one over the hypotenuse of the little one is the same thing as the short leg over of the larger one over the short leg of the small one. And it creates a geometric mean. We have two of the same variable, and we can cross multiply and solve there. And then if we did the same thing with our medium triangle and our large triangle, it's the same thing. It's hypotenuse over hypotenuse equals long leg over long leg, and we end up with the geometric mean there as well. What this does for us is it allows us to find different relationships within these triangles, and I'm going to color code like crazy for you here on this first example. So if we look closely at this first example, they gave us two pieces of information on the littlest triangle and also my largest triangle. And if we look closely, they gave me the hypotenuse and the short leg. So really, if we go back up here, you could say that this is hypotenuse over hypotenuse equals short leg over short leg. And this is the large triangle, and this is the small triangle. So if we use that idea here, my hypotenuse of my large triangle is 24, and my hypotenuse of my little triangle is 10, and then if I used my short leg of my big triangle, that's 10, over my short leg of the little triangle, that's b. And I'm set up with a really nice, easy proportion to solve. We're going to cross multiply there, and I have 24b equals 100, so b is going to equal 2.4 there. So it makes solving these fairly easy. Go ahead and try this second one and see if you can find y. It's a very similar setup. I'm going to pause the video, you can try it, and then when you come back in, the answer will be there. Alright, welcome back in. So as you can see here, I set up using the exact same ratio. I did hypotenuse over hypotenuse equals short leg over short leg, and I got 26 over y equals y over 8. And once I solved out, I ended up having a radical because I had y squared. And taking my square root, I simplified, and I just used the perfect square method. I divide by the perfect squares until I find one that works. And here I ended up with 4 radical 13 as my answer for y. So what I want you to do is to look at this example here and this example here. What you can do for our example here when we're looking for finding w is the method we just used. You can look and see that in this smallest triangle they gave me the short leg and the long leg, and same thing in my medium triangle, so you could set up a proportion that way. In this one where you're trying to find all three, I would do what we did here where we broke it into 3 triangles and then set up 3 sets of proportions. Go ahead and try each of those, and when you come back in, the answers will be there for you. Alright, welcome back in. I'm going to start with w first. I set up my equation here. I did my short leg 8 over my short leg w plus 9 equals my long leg w plus 9 over my long leg 18. And when I cross multiplied, I ended up with excuse me, with a binomial. And simplifying it out, I ended up with w squared plus 18w minus 63. So I'm going to have to factor there. Two things that multiply to negative 63 and add to 18 were 21 and 3 and negative 3. And then reversing those signs, I have w equals negative 21 and 3. And since negative 21 plus 9 is not a real answer, it doesn't work in the geometry world because we can only have positive distances, the only possible answer there is 3 for W. Now, for X, Y, and Z, I broke out my 3 triangles, and then I had to use a combination of proportions, like I did here to find X, and then I used a lot of Pythagorean theorem. I found 7.7 by doing Pythagorean theorem of my largest triangle, and I got 7.7 there. And then I used that to work my way around. Using Pythagorean theorem to get Z once I had X, gave me 6.7, and then I used that to get Y. So it's kind of a process. My recommendation would be for you to pause the video here and look through the math of this. Pythagorean theorem is always a tool we can use, so just be encouraged to be able to use that as well. These are very difficult. That's why we've given an extra amount of time in class to practice these. I expect plenty of questions. They're not something that come very easily, so I promise you it will get better, but you do have to practice it. If you have any questions, please ask me in class, and I'll talk to you guys then. Have a great day. Bye-bye.